This is video number 2. Here we are going to discuss about the algorithm, minimum spanning tree algorithm. Two algorithms are there actually in the syllabus, Prim's algorithm and Kruskal's algorithm, and they are identified as the greedy minimum spanning tree rules. Prim's algorithm, starting with any root node and the frontier edge with the smallest weight. This is the main essence of the Prim's algorithm. The Prim's algorithm works with this particular concept. And in case of Kruskal algorithm, an edges in increasing weight skipping those whose addition would create a cycle. Now, Prim's algorithm, it also known as the Jarnik's algorithm, which is a greedy algorithm to find the minimum spanning tree for a weighted undirected graph. And it is clear that it is a subset of the edges forms a tree that includes every vertex where the total weight of all the edges in the tree is minimized. This particular algorithm operates by building this tree one vertex at a time and from an arbitrary starting vertex. This algorithm was originally developed in 1930 by sage mathematician Vyok Jarnik, and later it was rediscovered and republished by another computer scientist and whose name is Robert C. Prim in 1957 along with Asser W. DeCastra in 1959. Therefore, this particular algorithm is identified with different names. Sometimes it is called as Jarnik's algorithm, sometimes as the Prim-Jarnik algorithm, or sometimes as Prim-DeCastra algorithm or DJP algorithm. This algorithm, we can define that what are the different steps that can be considered or followed particularly in this algorithm. Let us discuss. Initialize a tree with a single vertex, and you have to select one arbitrary graph from this. Next, you have to grow the tree by one edge of the edges that connect tree to the vertices not yet in the tree, and you have to find the minimum weight edge and transfer it to the tree. And this step 2 has to be repeated again and again until all vertices are in the tree. So these are the steps that need to be followed or performed in the Prim's algorithm. When we talk about the algorithm, the complexity of algorithm is the important thing. Now, what is the complexity of this algorithm? The time complexity of this algorithm is totally dependent on the data structure that one is used by the graph and for ordering the edges by weight, which can be done using a priority key. Now, second algorithm, that is the Kruskal algorithm. It is again a minimum spanning tree algorithm, and this algorithm finds an edge of the least possible weight that connects any two trees in the forest. It is also a greedy algorithm in graph theory. Why this is the greedy algorithm? Because it finds a minimum spanning tree for a connected weighted graph, adding increasing cost arcs at each step. That's why this particular algorithm is also known as the greedy algorithm. Secondly, if the graph is not connected, then it finds a minimum spanning forest. Minimum spanning forest means a minimum spanning tree for each connected component. And this algorithm was first appeared in Proceedings of the American Mathematical Society in 1956, and it was written by Joseph Kruskal. Here I have written the statements of the algorithm. Kruskal's algorithm's statements are written here. Algorithm, right? Because you know it very well that our algorithms are always the simple English statement which represents that what are the steps that you need to do, that you need to perform. So you have to create a forest F. Forest means a set of trees. Remember this set of trees known as the forest, where each vertex in graph is separate tree. Create a set S containing all edges in the graph, and you have to create a set S, and that will contain all the edges in the graph. While S is non-empty and F is not yet spanning. Two conditions you have to remember. What is that? That S means the set which has been created, the edges of the graph, and F, that is the forest. So S should not be empty and F, that is not yet spanning. On that basis, the steps has to be performed. Remove an edge with minimum weight from S. You have to remove one edge from S. S means from the set. If the removed edge connects two different trees, then add it to the forest F, combining two trees into a single tree. And what you have to do, if you are removing any edge from set S, and if that edge connect two different trees, then add it to the forest. Forest, it means the set of trees, and combining two trees into a single tree. At the termination of the algorithm, we will find the result that the forest forms a minimum spanning forest of the graph. If the graph is connected, the forest has a single component and forms a minimum spanning tree. So this is the algorithm, and this can be even represented like this. I have used some statements here, and I have collected all these algorithms, statements, diagrams from the different internet websites and the different articles which are published in the internet. So easily you can be go through this, and the concept can be more clear even. So the here Kruskal G is there. A, you have assigned the A, and for each V is the element of G. G means here we have taken as the graph, and like this you have to continue. And what is the complexity of this algorithm? Remember one thing, when we learn the data structure concept, with each and every algorithm we try to find out the complexity of that algorithm. So in case of Kruskal algorithm can be shown to run in OE log E time, or equivalently OE log V time, where E is the number of edges in the graph and V is the number of vertices, all with the simple data structures. So these are the different concepts related to the Prim's and Kruskal algorithm. So thank you very much.